as you're working on Lab 4, I wanted to give you some pointers on things that might help you do your data analysis. Now this is the sheet. Some of it's a little easy to do, like calculating the average standard deviation, and other things you're going to want to remind yourself of this worksheet right here, which reminds you of how to do the different t-tests and statistical analysis. So if we go to our data, for instance, we've got things such as what is the average of my blank, we have what's the standard deviation of my blank, and then from there I'm able to calculate my limits of detection. So first thing I did was I made my graph, and within this graph you see a trend line. Now those trend line data points, they have a lot more sig figs than what is shown on the graph. So the first thing I personally did was over here I typed in my slope and my intercept, and I went equals slope, known y's, known x's. That way I have all of the digits that are contained within this trend line that you just can't see. And for the intercept, it's equals intercept, blah. Okay? So now, how did I use that? I was given the concentrations, the absorbances. Also, the AA automatically gave me some concentrations, but the AA forces the intercept to be 0. Now you can do that if you wanted to compare them and see how they do. And how you would do that. So if I wanted to do that, for instance, I would right click, format trend line, and then I would set my intercept at 0. Alright, and why that's interesting is I could see how that compares. So for instance, if I were to add a whole bunch more of my data points here, and so this is my intercept, so 1.23771 times 10 to the negative 2. If that is my slope, and I'm assuming 0 is my my intercept, then whenever I calculated this, which is simply converting this row from absorbances into concentrations, you normally just use the trend line. So you would say equals this value minus the slope here, so it's this value minus your intercept divided by your slope, and then what I did here is this extra things is this is the dilution I did. So I took that into account all within the same equation. Alright, so here's this using my trend line. Now if I wanted to do a very similar equation, for instance, but instead of using that slope and that intercept, I could copy this formula, paste the formula here, but instead of my slope and my intercept, I'm just instead going to do C12 divided by this value here, that being my slope, now times my dilution. Let it fix it, and now you can see it's slightly different. Okay, so that's this would be right here. This is if I force it to go through the intercept. This is what I did, or I wanted to choose to not force it through the intercept and allow the intercept to be whatever it is natively. I tend to prefer that because there is sometimes a slight absorbance to your DI water, which you see in some of your controls. Alright, so I wanted to show you that just in case, but for the most part you don't have to do that. Let's show you the part you do have to do. So now you've got your concentrations using the trend line, which would have been not forced through 0, so let me go change that. And now it's back to where it was before. Okay? So you would just simply take into account your dilution and make sure that you're also using the slope line to give you that. And now I've got an average of those 3 data points, and I've also got my standard deviations. So this theoretical, whenever I did this was what I had done. Yours is obviously different because you use different stock solutions than I did. So you'll calculate your theoretical there, and then your percent difference, remember, is the absolute value of the difference between your average and your theoretical divided by your average of your average and your theoretical. So 0.5 times your average plus your theoretical, and then that is a percentage. So 4% versus 41% is what I calculated for in water versus in corn syrup. Now I'm just showing you one of them, so I'm just comparing A and C. You will be comparing A and B, and you'll also be comparing the C with your A as well. And so all of that is explained right here. Okay, so first, your LOD and your LOQ. So in this case, I just simply took my average plus 3 times my standard deviation. That's my LODY. So then my LOQY is that, but 10 times my standard deviation. Then my LOD now, what you do, remember, is you're taking into account that trend line. So you're plugging in essentially your LOD minus the intercept divided by your slope. Same thing for your LOQ. So now I have my LOQs, and I can see that down to about 3.4 parts per million I'm able to detect and to quantitate. Okay, so then the next thing on the directions ask you to perform a t-test comparing the experimentally derived concentrations with each of their theoretical concentrations. So that's what I did here. This is a type 1 t-test. So first thing you have to do is you have to calculate your confidence intervals. Now if you just type in TINV alpha, comma 2, where 2 is your degrees of freedom, I get 2.92, which if you look this up in the table that I gave you in a handout, it's the exact same thing. I don't know why Excel is giving me a negative at this moment. Don't really know, so I took absolute value of that because it's going to be a positive number. Okay, and then we're going to use this one in type 2 in our type 2 t-test. So I went ahead and did that too, where TINV is 4 degrees of freedom, just for comparison and references. So for the first one, we're using this number. So remember, if you go back to this handout here, your confidence interval is your average plus or minus t times your standard deviation divided by n. So here I did minus that. So my average minus my standard deviation times my t divided by the square root of n, and in this case n is 3. And then I did the same thing right next to it, but this is plus here instead of minus. Okay, now I've just got my interval set up, and I can see that my theoretical is not in my confidence interval. And then same thing down here, except for this is way lower of numbers. So with this type 1 t-test, you're hoping to see whether or not your theoretical value is within the confidence interval for your data. Then for type 2 t-test. So type 2 t-test, what I did was I wanted to let Excel compute that for me because it's just so much easier. So with the type 2 t-test, what I did was I went up here to data, data analysis, to sample assuming equal variances, or you can also do unequal variances, so we'll do equal first. So it goes through, and I highlighted my averages and my other averages for my second data set. I told it my alpha was 0.05, and then I told it I wanted to output it over here. And so you can see we've got the same values that I have highlighted. And so the two in particular that you care about is t-calc, which is labeled t-stat, and t-table, which is t-critical. If your t-calc is greater than your t-table, then the two methods are statistically different, which we would think 15,000 and 10,000 are way different. Okay, let me do a comparison just so you can see the unequal variances. And remember how you would do an f-test to compare your averages, and so you can see our standard deviations are pretty similar here. But you would do an f-test to prove whether or not you do equal or unequal. So if we did unequal, it's the same process. You would choose your data set here, here, and then you would tell it where to output it. I'm going to move it over here. And now I've got my t-test assuming unequal variances. But either way, you are still ending up with a t-stat that is drastically different and drastically higher than my t-critical, at least for the corn syrup compared with that in water. And that was kind of the whole point. Now in thinking about these, you can think about what causes this to be different. So obviously this is way different than the theoretical. What could I do to improve this so that way my theoretical value is within my confidence interval? That's a good question for you to find out and think about. Or do you think which one is more accurate? Your experimentally derived or your theoretical? That's another good question to think about. Alright, so that is Lab 4. I will give you a video for Lab 5 shortly.